Hello, Aero Structure. Today I'll be doing an example showing you guys how to use Macaulay methods to solve for the bending moment of the cantilever beam. So suppose you are given a cantilever beam of length D equal 15 feet with a uniformly distributed load acting upward Q equal 100 pound per foot, and at point B, which is a distance A from the fixed end, A equal 10 feet, there's a downward reaction force FB. At the fixed end, point A, there's also another reaction force FA acting downwards, as well as a bending moment MA. And MA is given at 7250 pound foot. So in order to write out the Macaulay equation for bending moment, the first thing you have to do is to determine all of the unknown reaction force and moment. In this case, which are FA and FB. So in order to solve for FA and FB, first off we're gonna write out the summation of bending moment around point A, and my sign convention is that clockwise gonna positive and acting upwards on so be positive. So we have the summation around point 8 is gonna equal to MA plus FB times arm length of A minus Q times D, which is the reaction force caused by low Q multiplied by the moment arm D over 2, because it's acting right in the middle of the beam, and all of this is going to equal to 0. So rewrite this one in order to solve for B. We're going to have FB equal to Q D squared over 2 subtract MA on divided by 8. And if you put in the numbers, you're gonna have these, and it's gonna equal to 400 pounds. So that is FB. Now in order to solve for FA, you're gonna need to write out the summation of all the forces acting in y direction. So positive y direction. So you have y, you have x, and it's going to be negative FB because FB is acting downwards. Same for FA, and QD is positive because it's acting upward. And again, all of these is going to equal to 0. So FA is going to equal to minus FB plus Q times D, and you put in the number FB, we just found it right here, plus 100 times 15, it's gonna give you 1100 pound force. Now, so after having FA and FB, we can write down the equation of bending moment using Macaulay methods. That is M equal to plus MA x subtract 0 to the power of 0 plus, because we have the sign convention right here, clockwise going to be positive direction, and then you're going to subtract FA x minus 0 to power of 1 subtract FB x subtract A, because FB has a distance A from the fixed end of the beam. So plus Q over 2 x minus 0 to the power of 2. This is a power of 1 right here. So for the moment, it's going to be power of 0. For all of the point force, it's going to be power of 1, and loading is going to be power of 2. And this is really important right here. xa is going to equal to 1 if x is greater than a, and equal to 0 if x is smaller or equal to a. This is really important, because if x is any value smaller than a, it's not going to give you negative value, but in fact it's going to give you 0. And I'll tell you what, this problem is very similar to your last homework, to your last problem on the homework. So in that problem, you were asked to find out what combination of the moment and the distance a in order to minimize the maximum bending moment. In other words, you need to find out the minimums of maximum M right here using two constraints MA and A. You're also given Q in this problem. So what you are not given are FA and FB. So how are you going to do that? How are you going to solve for M using only two constraints MA and A with two no FA and FB? Well, I'll give you a hint right here. That is FA, FB. You need to rewrite them in terms of MA and A. So rewrite FA and FB in terms of MA and A. You'll be able to solve for M using MA and A. Good luck with that.